Okay, so for this problem, we're given a student's data, and that student is trying to find the heat of fusion of ice. We'll find what the student should calculate from that data and then compare it to the actual value. Heat of fusion, we're talking about HF. For water, the value should be 334. This student is not going to get 334, but that's okay. When we put ice into water, two different substances, two different temperatures, no reaction is happening, heat lost equals heat gained. For this problem though, we have to think about what the ice is going to do when the ice is at 0 degrees and it starts to receive some heat from this water that's going to cool down. Water will cool down, therefore the ice will warm up. At 0 degrees, when the ice is going to warm up, the first thing it does, it receives some heat. That heat, because it's already at 0, it's already at its melting point, that heat is going to go melt the ice. Q equals mHF. If the ice continues to receive heat, it'll now be melted ice that can warm up. All of that heat, essentially the heat involved to make the ice melt and warm up, 2 steps for the ice. All of that heat is equal to the heat that the water lost when the water was cooling down. This side's about the ice, this side's about the water. So the water, we know we have, oops, it shouldn't say Q equals. 50 grams, CP is 4.18, delta T, well let's see, the water was at 30 and it went to 8. 30 minus 8, 22 degrees. The final temperature is of both substances. The ice, we had 10 grams of ice. We don't know, we're pretending we don't know the HF. We're looking for the HF value. That 10 grams of ice, after it melts, is now no longer ice, it's liquid water. So I use 4.18 here. And we know that it's going to have melted at 0. So in terms of its change in temperature, it was at 0 even after it melted. It's still at 0. That's why this is a flat line. And it's going to heat up to 8. So the change here is also 8. Solving for x is giving me the student's value for heat of fusion. 50 times 4.18 times 22. 10x plus 334.4, subtracting the 334.4 from both sides, dividing by 10. That is, x is what I set up as the heat of fusion, as the HF value, so it's in joules per gram. That's the student's value. In terms of finding percent error is the absolute value of right minus wrong over right times 100. If a question on the test asks you for that formula, you would be given that formula. The right value is the right value of heat of fusion of water, the one we've always used, the one we'd expect it to be, 334. The wrong value is the student's lab data. Absolute value, because we don't care about the sign, times 100. Calculating this, including the times 100, we get 27.7